Thanks, man. Three terms. It's going to look something like this. Let's see if you guys, see if I can keep you from freaking out, because there's going to be a lot of letters here. Where the A, the B, and the C could be any number, right? How are we doing so far? Some of you guys might have seen this before. Some of you guys have even gotten to the point where you've done, like, do you remember the quadratic formula, for example? B squared minus 4AC, does that sound familiar? That's where the B and the A and the C come from, right? Those are the coefficients there. Let's go beyond that. This kind of problem is easy. We're going to break it down into two steps. If the A is 1, it's easy as hell. And I'm going to hopefully get you to the point where you agree with me on that. If A equals 1, it's easy. So we're going to focus on that first. And then we'll see if we can get to, well, what if A is something else than 1, right? So again, I think I told you earlier, I'm going to try to motivate what we do with an example of multiplying so we can see, okay, how do we go backwards now? Right? So I'm going to do several examples here, actually. So if A is 1, it could be, for example, x minus 4 times x plus 3. I just can't put like a 2 there, because then wouldn't that make that 2x squared? Right? I want to have the first number be a 1. So when you multiply that, what do you get?
X.
Minus 4x minus...
And then you get... Now where'd this number negative 1 come from up here? Can you see where the negative 1 is coming from anything in here? Can you see where the negative 12 is coming from anything in here? Negative 12 is coming from this times this, right? And negative 1 is coming from this plus that. Interesting. All right, let's do another one. X plus 8 times x plus 5. X squared.
X plus 5.
Plus 5x. Plus 8x. Plus 40, right? So then you get plus 13x. So it's a little easier to see now. In fact, you can see how you're always going to get this plus this here in the middle, right? So where did the 13 come from? It came from this number plus this number. Where did the 40 come from? That number times that number, right? And where's the x squared always coming from? X times x. So what we're trying to do right now is to figure out, okay, I got to get some clues for how to, if somebody gives me this, how do I go backwards? Shit. That's of course going to be harder. But we're trying to see with the pattern. Some of you guys might realize where I'm going with this. So if I give you now x squared plus 7x plus 10, where would that 10 have come from? Just like that 40 came from the last number times the last number here, right? The two last numbers. So the 10 must have came from the product of something. I know, I'm catching up. And then the 7 had to come from those two same numbers adding together. So I need two numbers that add to be 7,
5.
and they multiply to be 10. So of course they are. 5 and 2 makes 10, and 5 plus 2 makes 7. Okay, Jeff, woo, way to play with the numbers. But now we see that's exactly what I need. X squared is going to always be what and what?
X.
X and x. The problem is the blank spot's there. Well, we just figured out what goes there. 5 and 2, and in fact, more specifically, positive 5 and positive 2, right? So that's all there is to it for that kind of problem. That's why I say that's an easy freaking problem. It should be an easy problem. Yes? Yes, how did you learn?
The big X.
Master product. You don't really need it here because there's a 1 there,
Yeah,
right?
and then like you just use the 7 and 10, and then you put the 10 on top of the 7 bottom.
Good. And that's just a way to kind of reorganize it. I don't mind. Has anybody ever heard, and this is going to be funny at first if you haven't heard of this, but has anybody heard of a method called bottoms up?
Yes, so.
Some of you guys are like, no, I know that method, but I didn't know it applied to math. But I think it's called bottoms. I can't remember now. Bottoms up method is not allowed here. I'll tell you that. Unless, if you know it, if you can show me why it works. Because this method is easy, but it hides what it's doing. That's what I hate about it. The whole point here is for you guys to get practice with how to do stuff. And if you have a method that kind of does it for you, what the hell good is that? Right? So now what I've just done is I made everybody want to go out and find out what the hell it is. It sucks, but oh well, too bad. Just know that I won't accept it. I've got to see some of this kind of work up here. Right? Let's try another one. What about this?
I have a question about the first one. If we don't have 7 there, let's say another number, so we get the sum of that number? The sum of that number in the middle with the x?
All right, so let me, actually, we'll do that one. Well, I'm sorry, let me leave this up here. Look at this real quick. So 1a. Right, so another number in the middle, right?
Yeah.
What numbers add to be 11 and multiply to be 10?
Oh, that's my question. I know that.
What numbers do that?
10, 1.
10 and 1.
10 and
So 10 and 1 work, right? Because 10 times 1 is 10,
10 plus
and 10 plus 1 is 11.
Oh,
So how do I write the answer?
x plus 1.
Plus 1, okay.
So x
Plus 10. You found out that 10 and 1 are the numbers that have to go into those blanks. That's the whole idea here. We're trying to figure out what numbers have to go at the end. Whether the two numbers that do what? Multiply to be something, add to be something. Once I get them, I just fill them in, and I'm done. Because it's the only part I don't know. X squared is x and x. That part I know. I just don't know what numbers go here and here until I do this. Now, obviously, now it's really easy for me to make a problem that doesn't work. What two numbers multiply to be 10 and add to be 8? Considering what I just said, the quick answer is no numbers, Jeff. You just said it didn't work. But 10 and 1 makes 10 when you multiply, but they don't add to be 8, obviously. 5 and 2, they add to be 7. Any other way to factor 10? So what would you call that then? What's a number that we can't factor? It's called, I'm not solving anything. A number that I can't factor is called, okay, good. I was waiting for that, but it's not what I'm looking for. I like that. Not factorable. I love it. But more specifically, it's a prime number. Right? Prime numbers are numbers I can't break up anymore. That's why I call it prime factorization, because I know I stop when I can't break it up anymore. So the answer here would be prime. That's the answer I want to see. If you say not factorable, I'm okay with that, because you're gonna. No, it's not. It's still valid. You could say that here. Don't. I didn't mean to make you feel bad. That's a good answer. But it is actually more technically a prime number. Now going back to this now. The negatives throw people off. But all I know is, I know the two numbers that I'm going to use. Here I knew they both had to be positive, or they both had to be the same sign because they multiply to be positive, right? Mm-hmm. And they both had to be positive because they add to be positive. Now look at this. They multiply to be negative, so they have to be different signs. And they add to be minus, so the bigger one has to be negative. So what multiplies to be 10?
2, 5, minus 5.
Good. 2 and 5 make 10. If you make the 5 negative, it makes negative 3. I like it. You guys see that? So what you can do for yourself is, you got your negative 10. Start making a list. Don't actually even break it up. Just make a list. 10 and 1. Well, if the 10 is negative, that makes negative 9. If the 1 is negative, that makes 9. Nope. The only other way to do it is 2 and 5. If the 2 is negative, that makes positive 3. I'm going to add them, right? If the 5 is negative, that makes negative 3. That's what I want, 2 and negative 5. So again, how can I always start this off? X squared is x and x. The only problem is I don't know what goes there and there, but now I do. Minus 5 plus 2. It doesn't matter what order this is in, right? I can multiply this times this or this times this. I don't care. I can do it whatever order I want to. Okay, okay. Here, you guys try a couple real quick on your own. Could be. No, she's looking at this one. Oh. Don't mess Jeff up. Come on. It's not fair.
No. 6.
Because 3 and 4 would make 7. It would make
No,
negative
4
7
and
if they were
4.
both negative. What'd you say?
16.
Okay.
So you can see that if you're not really up on multiplying, you're not sure what 6 times 7 is, this kind of thing is going to suck a lot. Right? So you just have to know your multiplication. You just have to know. So you can work with these a little quicker. Right? Some of you guys are really good with your numbers. These should be damn quick. The better you are with your multiplication tables, the better, the easier these are. So up here, I start with, this is where I really start. I know this is x and x.
Okay.
I just don't know what goes here and what goes there to make the numbers work. Good. To make 12, it could be 3 and 4, but when you add those, if you make them both negative, that's still just negative 7. That's not. You know. Are you guys cool with the fact that they have to be the same sign?
Yes.
Why?
Because it's a negative.
Because it's a positive, right? The only way to multiply two numbers and have them come out positive is if they're the same sign, and they both have to be negative, because like Jeff said, they have to add to be negative. So that's out. That makes negative 7. It's no good. But like you guys said, 6 and 2, if they're both negative, make negative 8. So then you just put them in.
Oh yeah.
That's kind of crazy how simple that is. That's it. You're done. And real quick, before we go to this one, I told you earlier I would do this again. That problem is done, right? So now we do, we'll call it Jeff stuff. I just like to show you, make it a little more concrete, because this is very abstract, right? You guys with me? I mean, that's like, okay, X's and 2's and so on, whatever. But what you're really doing is you're factoring an infinite number of numbers at once. So if you want, as somebody says, how'd your day go? What'd you do today? Well, I factored an infinite number of numbers. Thank you very much. I don't know. I guess that doesn't impress anybody. That's for me. If X were 10, what would this thing be up here? What's x squared minus 8x plus 12? Let's figure that out, right? If x is 10, the number I start with is 100, is that cool? 10 squared minus 80 plus 12, and that's 20 plus 12 is 32. How are we doing so far? So if x is 10, x can be anything. So I just picked 10 just because I wanted to. So what number do I actually have here? Because this is one number. You guys realize that? X squared minus 8x plus 12 is one number. If somebody would just tell me what x is, all right, I just did. So that number is actually 32. That better be a way to factor 32, or this whole thing can go out the freaking window. So if x is 10, what's x minus 6?
4.
If x is 10, that's 4. And what's 10 minus 2?
8.
And what's 4 times 8? 32. So isn't 32 factor as 4 times 8? Isn't that one way to factor it, right? So this will always be, anything you plug in for x, whatever number that ends up, this will be a way to factor it. That's what you really are doing here. I want you to realize that. I mean, that's the concrete thing of what we're doing. So you can try to make x 27, see what you get, and sure enough, that'll be a way to factor whatever the number that is. How much do you really have to understand what I'm doing over here? Not at all. I really hope you do kind of understand, but if you don't, you never have to do this, all right? It's just my attempt to show you what you're actually doing. What about here? I like it. So they have to be different signs. So it's not 22 and 1. Obviously, that can never make 9. It's got to be 11 and 2. That's the only other way to do 22. And the bigger one has to be positive. So the 2's negative. So again, here's your x and x. And what numbers go in?
Negative.
I love it.
You have to write it that way.
What's up? Oh.
Just like any other sign. The sign that
Okay, so are you good with the 11 and the 2?
Yeah, I'm good with that.
Now, why are you good with the 11 and the 2? Because that makes 13.
No. Why the
It makes, exactly, that's my point. What makes 9 from 11 and 2? So if you have 11 and 2, how do you make 9 from it? Don't you have to make it negative 2? Good.
You have to write it that way. You can't do it. You can't do 11 plus. Switch 2 and 11. Right?
No, another valid answer would be this. These are both good, right? Because what's 7 times 8? Is it different from 8 times 7? I don't care what number you put first. They just both have to be there, right? Now the teacher part of me is like, I set the damn time the class is over, so I feel like doing something critical right now.
Why?
Exactly. Especially 11. If somebody comes in 30 minutes late and then leaves 30 minutes early, I'm like, okay. All right.
No, just because you said 2 more.
Well, just a game. 20 minutes.
All right. Here's the last one. Here's the last one.
You can keep going.
I know what I said earlier, but stay with me now. Don't make it too crazy.
I like it.
Is there a game room here on campus?
Sing it.
Is there a game room here on campus?
A game?
Yeah.
A game on campus.
Game room.
Oh, game room. No. I think some people might think the tech mall is a game room. But there's no pool tables over there. So you can play pool online, I think. I've seen some people doing that. Strong academic work. Now, what's wrong with this? A couple things is wrong with this is if I just wanted you to factor this directly. I said that we were going to deal with just the 1 out front, and evil Jeff puts a freaking 2. What the hell? Not that evil Jeff. There are 3 terms here, right? So I know it's not grouping or something. What did I say you always do first?
Greatest conflict.
GCF. And that will save your ass. I can't do shit with this the way it is. Because what's x cubed? X squared is x times x. What's x cubed? X to the 1.5? No, it's weird. So what comes out exactly? An x comes out and a 2. So what's left here? X squared.
Plus 4.
4. X
Plus 4.
plus 4. Now see what's left over. That's easy to do now, isn't it? That's why you always do GCF first, because either it's the only thing you can do or it makes it easier to do.
You take out.
Now here's the thing. Never lose this poor dude. If you write this, it's not right because you lost him. Take him for the ride. Right, he's done. He should just come all the way down. If you leave him out, it's not right because you can never make it all the way back up here. So what 2 numbers make this work? Here's XX. What 2 numbers add to before and multiply before? 2 and 2. And what's a slightly better way to write this? If you don't do this, it's fine. X plus 2 times x plus 2 is x plus 2 squared. So you're gonna, I'll take this or this. And I think the book might write it like this, but this is fine. All right. And that's fun. I'll let you guys go. Oh, man. So next time I'll have that handout that summarizes kind of all the methods, because you're going to finish up the methods next time.
Want me to stop it?
Oh, yeah.